Good evening, listeners and viewers. I'm your host of the Space Show, David Livingston. This is our Tuesday evening West Coast program, and thank you very much for tuning in. And when we conclude our discussion with Dr. Mike Griffin, please stick around because I do have a little bit of space show business that I would like to mention, but I don't want to take up time with our guest, who I believe is too important. And I want to give him the priority, not space show business. So Dr. Mike Griffin is back with us, and he really doesn't need an introduction. He's a previous NASA administrator in another administration, and he has been the Undersecretary of Defense for Research and Engineering. He is co-founder and co-president of Logic Q, which is a consulting company.
It's Logic, David. We pronounce it Logic.
Okay, thank you for that. And I can go on and on. His full bio is on the Space Show. If you really don't know who Mike is, please go to thespaceshow.com and you can read his bio. Mike recently testified before Congress to the House about China and American space leadership and our efforts to get back to the moon with people in 2028. Many of us on the Space Show are skeptical of that timeline for a lot of reasons, most of them engineering, and some of them, at least from me, because I'm not an engineer, are political and policy questions that I have, because I don't think our Congress is a great leader in anything. But we want to hear what Mike says. So, Mike, you did go before the House. Can you summarize and clarify that for us and tell us the basics of your two-launch system?
Well, sure. I'm sorry we don't have more viewers tonight. This is an important topic, although to contradict what you said earlier, I'm not an important person.
Well, it will be on YouTube and it will be on Substack, and then that's where the viewers will be. But we should have people joining us during the program. At least they told me they were going to join us. Also,
well, that's great. My point was this is an important topic, and I do take issue. I'm not an important person, but it is an important topic. I also, up front, I really need to allocate credit where due. My business partner and former DOD and former NASA colleague, Lisa Porter, contributed to the testimony. I would just have to say in a massive way. I was the witness, but the testimony was a joint product, and a good engineer never takes credit that doesn't belong to him. So anyway, so I just wanted to make that point. So regarding the hearing was really about the issue of what are the Chinese doing and how is the United States reacting to that. So I'll get to the architecture in just a moment, but the key points that we tried to make in the testimony, and of course the written testimony is available online through the House Science Committee, so you don't need me for it. But key points we tried to make is that China is going to the moon, and I mean there's just no fuzz on that. And for my part of the testimony, I provided to the Congress over a dozen references in public media. I made the point that this is not something you have to have a security clearance to know. It's all over the media to the extent that anyone in the United States listens to it. So China's going to the moon, and they're working aggressively on the various components that you have to go to the moon. And I listed those out. A heavy lift launch vehicle, a crew vehicle to return from moon to Earth, a lander to get from lunar orbit down to the surface, rover to traverse on the moon, spacesuits. They're doing all the stuff. They're testing it. They're publicizing the tests. They're on YouTube. You can watch them demonstrating a launch abort system or a lander test. It's just not a secret. We don't seem to be reacting to it. And one of the points I made was that, we can't control what China's doing and frankly shouldn't try. we can only control what we're doing. And I made the point that our response, I think the phrase I used was that mediocrity would be an upgrade, which got some attention. But, it's true, because you can't beat something with nothing. We tried in the testimony to make the points that it really matters whether or not your nation and its allies and partners are on the frontier or watching on TV while other people are on the frontier, because the nations of the world want to align themselves with the people that they think are leading. And if China can get to the moon and we cannot and are not even trying, then it's really pretty clear to most nations of the world that China is the big dog. They would be the global power. That's not something I want for our country, which was why I agreed to testify. So that's the kind of geopolitical issue. Now, in the testimony, we pointed out that on the public record is China's approach. It's a dual launch scenario where they launch a lander and park it in lunar orbit. And then they launch a crew vehicle with, of course, the crew and rendezvous with the lander in lunar orbit. So in that sense, it's unlike Apollo. It uses 2 launches instead of 1. They go down to the surface, come back up to the crew vehicle, and come home. So in that sense, that part of the Chinese plan looks an awful lot like Apollo, but that's not because they're copying anything. It's because the physics of the problem aim you in that direction. And I pointed out that it's a nice, simple, straightforward architecture, and frankly, we could learn from that. Then I referred to my testimony of 23 months ago, where I said basically the same thing: is that our approach is not going to work. And the reason that it is not going to work are a couple of really key. So I'm sorry, let me back up. I offered also, there are many architectures that one could use from a systems engineering point of view to get to the moon. I offered one, but there are others. I offered also a dual launch scenario using the only heavy lift vehicle that the United States currently has, which is the SLS. And I devoutly hope that others come along, because I was saying before, when you and I were chatting, David, before we started, I said that the United States needs all the space lift that it can get. So I'm very pleased to see the progress that Blue Origin has made with New Glenn, and I hope for more progress with SpaceX's Starship. I'd like to see ULA get into the heavy lift game, but right now what we have is SLS. So I designed a space systems architecture around the use of 2 SLSs as another dual launch scenario approach, and very similar to what, at the time I didn't know it, but very similar to what the Chinese are doing. Deploy a lander to low lunar orbit, park it there, take the crew out on a crew vehicle with the second launch, rendezvous with the lander, and so on from there. I wouldn't, just for the fun of it, sit down and design space systems architectures if I thought the plan we had was going to work. And the Artemis III plan, in my view, can't work. And I have 2 basic reasons for that. The first of which is that, but I shouldn't say it can't work in any reasonable amount of time, because there's an awful lot of technology development totally undone, yet to be done, in order to refuel a transfer cryogenic propellant from a tanker to an upper stage. That's a major technical challenge, and you just don't put, just as a matter of programmatic cleanliness, you never ever put a TRL-1 technology, meaning something that's never been demonstrated. You never put a technology like that in series with a flight program. We, of course, did it in Apollo, and we used up 4% of the nation's budget in the peak years to do it. We did it in the Manhattan Project, developing nuclear weapons. But absent something like that, you just do not put, a TRL-1 technology in series with a schedule-driven program. So it's not going to work anytime soon. The second major technical issue with the current Artemis III architecture is that if you got the cryogenic propellant into the lander, either the Starship lander or the Blue Origin lander, keeping it as a cryogenic propellant for days at a time, and in the case of the lunar lander, the NASA specification is 60 days as a threshold requirement and 90 days as a goal. We just don't know how to keep the propellant that cold for that long. And I can't stress enough that this is an unsolved problem. What you must do to make the current Artemis architecture work is the equivalent of taking a hydrogen tank or a methane tank in a tank farm at Kennedy Space Center or Vandenberg and putting it in orbit and keeping it refrigerated. Now, can that be done? I mean, does that violate the laws of physics? No, of course not. But doing it in something that can be flight weight, we're a long way from that goal. So that's my second reason that I don't think it can be done in anything like the near term. And I'm about to conclude. I'm sorry for monologuing, but you asked about the testimony. And I made the point in the paper that if it could be done, it shouldn't be done, because the orbit design that NASA has selected, and this was provided to the contractors, it's not their invention. I can't blame the contractors for responding to what NASA asked. The near rectilinear halo orbit provides a landing opportunity and a recovery opportunity only every 6.5 days. And there's some fuzz around that, but after a little period before and after the optimal point, the crew just cannot get home for another 6.5 days. And I just would never sign up to an architecture where the crew is stranded on the moon for days at a time and can't get off in the event of an emergency. So that's why I say it shouldn't be done. So those were the key, and then, okay, for completeness, the testimony, the written testimony contains a summary of the space systems architecture that I designed and did offer, but that's less relevant. I've had that out there in the public for years now. So that's about it, David. You asked for a quick summary of the testimony. That's about it.
So, assuming that the program of record was switched to this program or one comparable, we're talking about a 2028 timeline. So let's say, I guess, the whole year of 2028. So is there time to build all of this, to do this, to perfect it, to get it tested and done?
The only thing that needs to be built for the architecture that I offered is a new lander. Now, you're going to have to do some modifications to Orion to give it a better sun shield than what it has, but that's kind of trivial. We don't have a lander, and it's 3 years until the end of 2028, and it took us, let's see, the lander contract was provided to Grumman in 1962, November of 62, as I recall, and it had its first flight unmanned in 68. So it was 4 years and 2 or 3 months. We want, the NASA specification calls for 4 people for a week. We need something better to meet that spec. We need something better than the Apollo lunar lander, and I would hope that 50 years later we could do a little bit better. So the lander is the pacing item. Pardon me.
What?
I think it would be nearly I don't like to use the word impossible. This is a country that, went from a standing start, and 8 years and 2 months later, the country put people on the moon. And, starting in 1942, and by 1945, we had an atomic weapon that ended World War II. So I don't want to say that something is impossible for this nation to do, but it would require a huge commitment.
What is the process to switch the program of record to what you're talking about? And is it a congressional job to do it, or where does it even begin?
Well, I don't know that there is a process, David. Honestly, the new administrator of NASA would have to decide that he wants to find out what all the controversy is about. Because I will tell you from I've been confirmed by the Senate in 2 jobs, and the primary rule that you cannot engage with the agency for which you're being confirmed. Okay? Because it creates a, quote, presumption of confirmation. You're presuming that the Senate will confirm you, which they regard as their prerogative. So Jared may have been reading the public press. I hope he was, but it would not have been possible for him to dig into what's going on at NASA because he was waiting to be confirmed. He was confirmed last week. I hope that he will decide to investigate what all the media controversy is about and, make his own judgments. But that's the first thing that has to happen. Then he would have to go to his boss, the president, through the chief of staff at the White House, and say, boss, this dog won't hunt. And the president would have to agree with him that he wants to make a change if he wants to have any chance of not being the president who gave the moon to China. And then the president would have to propose that change to the Congress, and the Congress would have to agree and appropriate the money to do it. And then, frankly, I don't think we have much time for a lot of industry competition. I think you'd have to make some sole source assignments of what you want the various contractors to do, and that's the minimum of what you have to do. Somebody would have to be put in charge of the actual program who had some idea what they were, what spaceflight was all about. But that comes after the president has decided that he needs to make a change and the Congress has agreed.
Phil, you want to jump in?
Yeah, I was wondering, do you feel that there's a team at NASA that already has a very accurate and absolute understanding of the Artemis program and all its components, including, the components delivered by commercial providers such as SpaceX? And this understanding is solid enough to make a kind of a decision as to whether or not they're on track or not on track, or if it's still too ambiguous to make such a decision, it has to be improved in some way.
I have not been the administrator of NASA for 16 years and 11 months, so I don't know. It would be completely unfair of me to say what the current NASA career leadership knows or doesn't know. I just can't comment on that. I can only comment on what is publicly articulated by the agency, and what is publicly articulated by the agency and frankly the last 2 presidential administrations is an architecture that will not work. And it doesn't need more study to know that it will not work. Now, again, in order to know, the worst thing that somebody can do, well, not the worst thing, people can do lots of really bad things. A bad thing for an engineer to do is to criticize someone's approach and not have an alternative. The old saying, don't bring your boss problems, bring your boss solutions. So I've offered a solution. There are other approaches that can work, and it's up to the judgment of the responsible officials to determine which one they want to pursue. But there's at least one that will work, as opposed to the current one, which will not work. You really need to get your head around that. It's not going to work. Okay, so then the question becomes, okay, well, what do you do? But people act as if, oh, that's just Mike over in the corner saying it won't work. But, why don't we wait and find out? Okay, wait and find out. Spend the money, spend the time, wait and find out. It's not going to work.
So if I could follow up, I personally do agree with you, but I've also engaged with people who don't agree with that point of view.
Well, I know.
I've observed some of the reasons why they don't agree. Sometimes I feel like they don't agree because they've oversimplified some of the analysis of the rocket equation, for example. They didn't consider the structural strength of the rocket as it's launching when they modeled it, or something to that effect, right? They didn't consider boil-off enough. There's a lot of technical reasons, but I feel like the only way you're going to get to the bottom of that is to have a team of experts in rocketry and telemetry guidance to actually put together a very detailed report. But I doubt that report exists today. That's what I kind of want to get some insight into.
I don't have any idea. I really don't know, Phil, whether or not there's a detailed analysis at NASA on it. But I don't care.
Would there be?
Okay, honestly, I guidance equations and guidance hardware and structural strength of materials and all of that is I want to be very clear. Those are important things if you're actually designing something that might work. Okay, but when you do not know how to transfer cryogenic propellant, and you need at least the most optimistic estimates are 10 flights to do something that no one knows how to do yet, and then you need, while you're doing all those flights, you need to keep the cryogenic propellant cold, liquefied. We don't know how to do that in space for long periods of time at all. So when you have two things that you don't know how to do, okay, then not in any reasonable time is your program going to work. So spending time in analyzing all the important details that you would want to analyze if it could work, you're wasting your time. And then again, back to my point, if it could work, it shouldn't. Because you're some NASA administrator of the future, when they finally get that in play, some NASA administrator of the future is going to have to sign up to risking a crew on the surface of the moon who, if for any reason they need to depart from the timeline, if rendezvousing 6.5 days later after they land, if for any reason they need to change that timeline, they can't do it. So they'll die.
Mm-hmm. Wasn't this obvious from when they even started on the current concept back several years ago? The same thing
yes,
you're saying.
Was. I wrote a paper up on that within a few weeks after the decision was published, and the late Tom Stafford, General Stafford, former Apollo astronaut, took it in to Bill Nelson. Because he and Bill were friends. I didn't have my name on it because my name on it would be the kiss of death. Tom took it into Bill, and Bill wasn't interested. So, and I tried several other routes without having my name on it. That was back in the second half of 2021. I was asked to testify 2 years ago, 23 months ago. I testified to the same things I'm saying now, and no one noticed. So yeah, it's been obvious for years that it was not going to work.
Marshall?
In fairness, it's not going to work in any reasonably knowable time frame.
Marshall, you're muted. If you want to talk, unmute.
Every time. My question is, everybody talks about the boil-off and temperatures and so on, but they're usually referencing it in orbit and on the way to the moon. And I see the real problem is if you're staying 6 days on a sunlit lunar surface that's over 200 degrees I think it's Fahrenheit, you're going to have a real boil-off problem because there isn't any place to get rid of the heat.
I say that all the time. That's also in the paper. Yes.
Oh, okay.
Okay.
But who's the specialist on it? Do you know?
Well, there have been some papers written on cryogenic boil-off control. The longest experience we have is with Atlas Centaur that, for 2 or 3 days. So we just don't have a lot of experience with it, and we don't have any significant experience with it, and it's obviously a major problem. And it's likely to be worse on the surface.
Yeah.
The SpaceX engineers that propose all of this and say they can do it, what do they see differently than you and Marshall and Phil and other people?
I have no idea.
Well, they got to see something different to give them a different position or a different perspective or a different number.
Then you need to invite them to be on the space show. I'm not employed by SpaceX. I don't know what they see or don't. I'm certainly not going to criticize any individual engineer who's is confronted with a problem. They're trying to figure out how to keep cryogenic propellant cold for days, weeks, and months at a time. I wish them luck. But my judgment is that they will not have the luck that I wish them. There is an old saying that no amount of brilliant engineering will ever rescue a bad concept. Okay?
Yeah.
You can have brilliant engineers working on something that doesn't violate the laws of physics, but being able to get through all the steps you have to do to convert a concept into a solid piece of hardware, it ends up never closing. And, there are too many examples.
Do you believe that Congress thinks we have a real crisis on our hands in getting to the moon before China?
I don't know. I'm not well enough connected anymore to know what the Congress thinks. They asked me to testify twice. I've done so. They had other testimony in September by another former administrator, Jim Bridenstine, who self-admittedly is not an engineer. He's an ex-carrier pilot. But even Jim could see it's not going to close. So I don't know what to tell you, David.
Well, I wish somebody could tell me something, because it is, to me, it's like there's nobody is willing to say the emperor has no clothes, and the people who do speak up are dismissed. And we just keep marching down the same parade grounds.
I'm willing to say the emperor has no clothes. I've said the emperor.
I mean, within the group that's making the policy and the decisions.
I mean, we have a naked emperor here, so I don't know what else to say.
I'd like to see a policy decision and solution, realizing that we've got a real engineering dilemma on our hands, if in fact the goal is really to get there before China. And I think that's an admirable goal.
Well, yes, I'd like us to be there before China. But we were there before China.
Right.
Okay. What I don't want is, personally, this is just me, what I think is poorly advised for the United States and its allies or potential allies in the world is a situation where China is on the space frontier and the United States is not even trying. Okay, it is a measure of a great nation that it is on the frontiers of its time. There is no great world power that was not on the frontiers of its time. So that should be a given for the United States, that we are no less than first among equals. We don't want to prevent anybody else. We have no intention to prevent someone else from, exploring and utilizing space, but everybody should be watching what we're doing, not watching what the Chinese are doing.
Could I ask, now that Isaacman is the NASA administrator, do you see yourself speaking with him one-on-one and seeing where his understanding is and perhaps help guide him along?
I don't know Jared. He has no reason to call me or talk to me. If he wants to, I'll certainly do so, but I don't thrust myself on other people. I've testified twice on this topic because I was asked, not because I asked them. I have no intention of putting myself forward. I don't like being a public figure. I never liked it. I like it even less now that it's not my job. If I've had 5 jobs where I had to be a public figure. Anybody at NASA, absolutely everybody at NASA, from top to bottom, knows what I think because it has been in the media 2 years ago and then now. If they want to talk to me, they'll call.
Isn't one of the big problems with the current architecture that we went with a baby version of the SLS rather than the full Block 2, so we don't have enough Delta V to do what we really need to do? The underpowered ESA service module, and of course, like you're saying, the lack of a lunar lander that's credible.
Well, yeah, those are all problems. However, there are bigger problems and littler problems. The approach I offered makes up for the underpowered SLS. Okay, we do want the Block 2, but the approach I offered will get you around the fact that the SLS is not the Ares 5 that we were going to build in Enduring Constellation. So you can Band-Aid that. Let's see, you mentioned
the ESA service module.
Yeah, the underpowered service module. Again, the approach I offered gets you around that. So again, those are Band-Aids. Yeah, absolutely. It would be better to have a healthy service module and better to have gone straight to the SLS Block 2. Would also have been better for Congress to fund it like it needed to be funded, for NASA to have managed it correctly, and for Boeing to have said, we've been handed a sole source to build the space equivalent of the 787, and we damn well need to do it instead of just regarding it as a jobs program.
Mm-hmm.
Boeing doesn't need anybody to tell them how to build a big launch vehicle.
And I guess you prefer a lander that has used storable liquids rather than cryogenics.
Well, for the moment, yes. Now, let me be clear. Cryogenics. I don't have to tell you this, John. I'm totally sure you know it. Cryogenics have a lot better performance. When we have enough infrastructure on the moon in decades to come, where we can have a tank farm that is like the equivalent of what we find at KSC in Vandenberg, well, then cryogenics will be great. You land and you fuel up, and you don't go there until you know you've got propellant to come home. It's not that cryogenics are never going to be useful on the moon, but when you're going back for the first time in 60 years, I'd prefer not to risk a crew on something as fragile as a cryogenic propulsion system. That's just my thought. I want it to be as simple and safe and certain of accomplishment as it can be. And we're in the Lewis and Clark expedition era. We're not in the interstate highway across Montana issue or era. That's not where we are. We say we've been to the moon. Yeah, we went to the moon 60 years ago. 60 years after Lewis and Clark, we were, doing the California gold rush.
Yep.
AJ, go ahead.
Yeah. I think in your paper, which is at the bottom of the below the testimony, you mentioned that people have questioned that the need or the problem with that many refuelings is that it could be just simply another one can be sent up. And I obviously don't agree with them, and I agree with what you say, but you say that that is really not true in the sense that it could have more of a problem in terms of something that they've already worked on. The first thing that they're going to send up, the depot blowing up or something like that. And the other thing is that I saw that what SpaceX, I'm talking of course about SpaceX here, SpaceX would send out the depot first, and then they'll have to send out 10 to whatever, 20 or whatever it is. The number is, Dan Dumbacher said the number is going to be 20 or to 40, and like that. But that particular depot then will have to refuel or fuel the upper stage or HLS that they will send at the end of refuelings. So that's double refueling basically, and that's really is also that could be quite problematic, dangerous, etc. So can you just sort of tell us your, I guess, the thinking that you kind of mentioned in your paper, but that just is not a question of just a simple single thing that can not work, but it's kind of, it can have a cumulative effect.
Well, yeah, the point, again, let me back up. Refueling in space, propellant transfer in space for cryogenic liquids has never been demonstrated. Mm. All right, so let's fast forward and say we now know how to do it at some future date. All right, if you're going to have multiple launches, and as you say, the numbers between 10 and 40 have been tossed around, but nobody knows. And the same, by the way, is true of the Blue Origin architecture. They're the same in that way. Mm-hmm. In the testimony that I provided and the paper that Lisa and I, my business partner, wrote, let's assume that you have a 98% success rate. Well, after you've done 20 launches or 15 launches, you don't have a very good probability of completing the mission because the odds are that something will fail. Okay, then those are computable, and I gave some numbers in the paper.
Yeah, 74%.
And then, as you pointed out, a number of people have told me, and I get that criticism all the time. Well, if we lose a tanker, we'll just launch another tanker. And my point in response to that is, wait a minute, every time we lose a significant aircraft or a space launch vehicle, we ground the fleet and don't launch again until we understand the problem and solve it. So why is this going to be different? We're now all of a sudden, if we lose a big rocket that causes mission risk, we're just going to launch another one? That seems to me it lacks credibility because it completely departs from the history of air and space flight. It's that. Yeah. That's simple. I can use more words, but to no point.
In terms of Blue Origin, I actually, with my space-side code, I designed the upper stage of Blue Origin, which turned out to be about 10.5 ton, which puts 45 ton to LEO. Now, in the Blue Origin concept, which is figure 6 or 7, I think 6 of your paper, it's showing that the Blue Origin will also, of course, do the refueling. In that case, the 140 ton of fuel is what the Blue Origin second stage carries, according to my calculations or design. But the other, the lander, the crew lander, which in this case would have to be Mark II to be able to take 4 people or astronauts to the moon. That is 45 to 46 ton, fully fueled, of course. In this case, also they are saying that they will send it out empty to LEO, which is about 16 ton, plus whatever the weight of the other things would be. But would that leave enough fuel in the upper stage to be able to do TLI, and also they have to do LOI with that stage? And then, of course, they are refueling in NRHO, which is just very problematic, even more problematic than in LEO. So I just I find it very hard to believe all these ideas.
I should let you do the show, because I don't know anything about the Blue Origin system designs. I have no inside information. I haven't done calculations. I see no point in doing detailed calculations when you are starting with a concept that cannot work in anything like the time that was specified. I can't emphasize enough. I don't care about getting the details right when the basic concept will not work.
Which is the NRHO concept, you mean?
Well, NRHO combined with multiple refueling flights, combined with the fact that we can't keep the cryogenic liquid cold with units that are flight weight. I mean, I know how to make everybody on this call knows how to make a refrigerator. We had that in freshman physics. We know how to make a refrigerator. Refrigerators can be made that will work in space. Can they work in space and be made flight weight to go to the moon? Not anytime soon.
Mike, is there a point of no return that requires our action? And if we pass that point, there's no way, no matter what we do, we're getting to the moon. And what would that point of no return be?
I guess by our you mean the nation, because no one's listening to me or to this group. Well, it's not a slam dunk for China either. So I don't know what the point of no return would be. I've already said it matters, for me, my opinion, it matters less that China gets back to the moon before we get back to the moon than that they are working on settling the space frontier and we're not. Okay?
Mm-hmm.
The tortoise and the hare comes to mind. If we're not even in the game, then that bothers me a lot. But with regard to the issue of timing and, quote, points of no return, unquote, there's never a point of no return. We could always decide that we're going to re-engage. I hope we do. And, oh, by the way, as I said a moment ago, China does not have a guaranteed success here. Going to the moon is not a slam dunk for anybody. And if they were a couple of years late, we would certainly regret not having been in the game. And it wouldn't be unusual to be a few years late doing something this difficult. We act as if going to the moon and coming back home and not killing people, we act like, oh, that's just no problem. Well, it's not no problem. It's really hard.
So, Mike, is there a process that you're familiar with by which somebody would be able to convince you that it could work? Like calculate all these probabilities, do the right tests to show that the TRL level of various technologies was higher than maybe you thought it was, And if there's such a process, can you describe how it would work and what your expectations would be about somebody who would approach you with a convincing argument?
Well, yeah, I change my mind all the time in the presence of facts. So I would have to see an orbital flight test where cryogenic propellant was transferred and, how much was lost in the process, if any. And then once the propellant was transferred, how well its temperature could be maintained on orbit in a vehicle that, has to fly to the moon. Because the lander has to fly to the moon, and it has to hang out in lunar orbit for weeks at a time. Okay. So I would have to see an orbital flight test to believe that. That's not something calculations are going to do for you. Anybody, not just me, I quoted a number in the paper, but anybody who knows the engineering literature can look up and get numbers for, I'll just say the best boil-off percentage per day that has been demonstrated, and similarly the best that people think they might be able to do. So it comes down to how much prop do you think you're going to lose every day? And if you take the most optimistic numbers I know, it doesn't allow the mission to close. Now, if you can truly get to zero boil-off, which, by the way, we don't even do at the Cape because we have to replenish, but if you can design and again, we know how to design refrigerators, so if you can design a system that doesn't lose any prop and keeps the system cold enough that you don't overpressure the tank and rupture it, then yeah. Right? But that requires demonstrations. Let me point out, and let me just ask if everybody remembers, before a shuttle launched, what was the last thing that happened? The little beanie cap pulled away from the top. Okay.
Oh.
That was to absorb the propellant boil off.
Mm-hmm. Yep.
To keep the tank from overpressuring.
Mm-hmm. Yeah.
So in Phil, when you say what would convince me, I need to see an orbital flight test before I'm going to commit people to something like that. And not only that, the nation's treasure, I need to see an orbital flight test. And I don't go and design a mission that's going to use up billions of dollars and the nation's credibility. I'm not going to design a mission that depends on technologies that have never been demonstrated.
I'm sort of reminded, and I'm being a little bit of a devil's advocate here, but I'm reminded that the space shuttle was put on the pad with 2 crew members in it and launched for the first time successfully, which I thought was pretty amazing. I was pretty scared for those guys. In order to be able to do that, there must have been lots of ground tests and simulations and calculations that everybody relied on to be sure that they could do that. I'm wondering if something like that could convince you, like a very thorough analysis.
Well, no, it was more than an analysis. You just mentioned a bunch of tests. So, yeah, in fact, while I was administrator, we celebrated the 25th anniversary of that flight. And for public quote, I offered that it was the boldest test flight in history. Okay, that was my quote, that it was the boldest test flight in history. And both the commander and both John and Kripp told me they really appreciated that quote. They agreed with it. But it took I mean, the United States has done amazing things. I think I said that some minutes ago. But there's an enormous amount of difference between the testing and the analysis that was done on shuttle and the testing that's been proposed for Artemis so far. Okay.
I have a interesting point, and that is, would it be better in the national interest to try to build a new space station, a really high-quality space station, rather than going to the moon for national prestige?
Well, my opinion on that back when we were building the first space station was no. Okay, you don't. You build a space station to serve mission needs. Okay, space stations could have multiple purposes. You could certainly design a research station that wouldn't look like the one we built. You could certainly design a station as a transfer node. In fact, in the future, I think it would be highly efficient to have maybe a couple of stations that would be transfer nodes for people and cargo to and from the moon and hopefully later to Mars. But you don't start there, in my opinion. Jefferson didn't ask Lewis and Clark to build St. Joseph, Missouri before they set out for the West Coast.
Yeah. But in the near future, the two come together and need to be.
There are no transportation systems that don't have nodes. Railroads have marshaling yards and terminal stations.
Right.
Ships have harbors. Airplanes have airports. My airplane is parked at the airport nearest to me. I don't have it in my yard. Okay. Interstate highways have fueling stations and rest stops. There are no transportation systems that don't have nodes to make them operate more efficiently. I seriously doubt that space transportation will be the first to not make effective use of transportation nodes. We have not so far done it, but I believe that we will. But it doesn't come ahead of the initial exploration, in my view.
One idea I've been thinking about, it won't be timely for the first return to the moon, but what if instead of using the SpaceX concept of like a tanker concept for multiple launches, refueling launch by launch, you construct a station, an infrastructure where the fuel would be stored up.
That is exactly what I have
going to refrigerate.
Yeah.
And then,
that is exactly what I have said. If you want to use a refueling architecture, I can give you one. It's going to take a lot more time, but you build yourself a large propellant depot and you fuel it up with as many flights as you can fuel it, and you buy flights from anybody who can give them to you. Okay? And you fill up the depot, and then when the depot is filled up, you fly to the moon. Okay? Now, you still have the problem, as was pointed out earlier, when you're on the moon, that's not going to save your ass. All right, because you're still going to get a lot of heat input, and you have to hang out in lunar orbit for long periods of time. So you still need cryogenic fluid management that we don't have. But if you want to do a low Earth orbit rendezvous approach where you use a propellant depot, that's the way you do it. What you're talking about. You don't use multiple refueling flights to fill up your flight vehicle. You use the multiple refueling flights to fill up the depot, and then you fly when it's full.
Yeah.
I see that. Yeah. I don't fly my airplane across country, and I have by stopping every 50 miles to put gas in the tank. And I make sure there are places I can stop along the way to get the gas.
So it sounds like, based on what you're describing, that given the technology gap that we're seeing, that eventually this is going to what NASA is doing is going to move forward up to a point, and then it'll just screech to a halt because that technology is not there.
That's right. And then everybody will be blaming everybody else, and we will be very far behind the Chinese. I'm actually not worried about the crew risk because it's not ever going to get that far. If it were to get that far, I would be worried about the crew risk, but it's not. But your point you make a very good point. Point I make all the time, that it's eventually just going to crash because it can't work. So then I've been told by several people, well, but that train's already left the station. We can't fix it. And my response to that is, well, if the train is going over a cliff, maybe you should stop and back up.
I had a thought on that. You triggered an idea here. So if Jared Isaacman, Director Jared Isaacman, after a few days in his position, comes to agree with your point of view, I still think there's a huge challenge, kind of a political challenge or leadership challenge for him.
Oh, enormous.
Yeah. What are your thoughts on how he could go about, steering the ship onto the better path?
I have absolutely nothing to say about what Jared could or should do. I have been where he is. I cannot tell you how much I wish him luck. Okay. When I took over NASA, we were a couple of months from our first shuttle return to flight mission, and not widely known, but it didn't go well. We lost a huge chunk of debris after supposedly 2 years. So I didn't have any reason to not fly that first flight, but after that first return to flight, I grounded the fleet. And nobody remembers all that. It was 20 years ago. Nobody remembers, which is fine. The point is that I got the crap beat out of me on the Hill and in the press for grounding the shuttle. And one of President Bush's senior staff did me a real favor by calling me up and saying, the president wants you to know that whatever you think we need to do, that's what we're going to do. All right. And the fleet stayed grounded for a year until we actually, Bill Gerstenmaier led a team of people to figure out what was causing us to lose foam. And the next time we flew very well. And we flew well. We flew well out to the end of the program. But it's really, really, really hard because of the politics, to make a major change. So I wish the new administrator all the luck he can ever have. But I'm not going to presume to suggest what he should do or how he should do it. That would be, that would be unfair.
Is it sort of a fair perspective to believe that our media so compounds the problem that it makes it almost unsolvable, if not unsolvable?
No, I'm not blaming the media or anyone else. I'm saying my comments have been strictly technical tonight and not kept them technical. Mm-hmm. Okay? This approach is not going to work. It is not one of the system engineering approaches that can work. There are other approaches that can work. Maybe we should pick one of those. And I've stated my reasons for why I don't believe it can work, again, one more time, in any reasonable amount of time. Are human beings, if you ask the question and turn it on its head, are human beings ever going to learn how to do cryopropellant transfer and storage in orbit? Yeah, of course. We are. It doesn't violate laws of physics. We will learn how to do it. We're not going to learn how to do it soon.
I have an interesting point from a management point of view. You're almost saying that you have to have a spectacular disaster to get stuff done, because you have to convince so many people that their idea is wrong, and it only happens when, you have a spectacular blow up. And isn't that kind of how the United States always works? Well, I was going to say it's almost what Elon Musk does with Starship.
Yeah, that's a different thing. Elon is experimenting rationally and efficiently, by combining analysis and tests, just like we did in the 60s and 70s when I grew up in the business. Okay,
But he doesn't have to convince Congress, and to convince Congress that something doesn't work, you almost have to have a disaster. So
I'm not going to blame the Congress or anyone else. I'm saying we have a technical architecture that won't work, and it is likely true, because people don't see why it won't work, that it will have to first not work, and then there will be the usual blaming and finger pointing, and then they'll produce something that will work. But our inability to see the obvious thing in front of us is legendary. It was completely foreseeable in the late 1930s that Hitler was not going to stop unless somebody stopped him. And oh, by the way, the United States didn't declare war on Hitler. He declared war on the United States after Pearl Harbor. Okay. So the other nations of the world were busy trying to stop the Japanese and the Germans in the late 1930s, and it was 2.5 years later before we got into it. How many lives are lost because of that inability to see the future?
Yeah. And that's kind of the theory I was thinking about. Thank you.
So
that's just how we are.
What gets me is that you say there are options on the table besides your option, but we're not talking collectively, nationally, about anything on the table. Train is going down the train.
NASA has the responsibility to pick an approach, and they have a responsibility to pick the right approach, or one of the right approaches. And it's not, the responsibility doesn't lie anywhere else. It's not up to a national referendum to decide how we're going to return to the moon. And David, it's past the hour, so I would say time to say goodnight.
One last question. Does NASA, having been there, respond to public pressure at all? Is that effective with NASA?
Well, no, nor should it be. You can't decide technical questions by a public vote. Okay, it was a technical question as to whether masks were effective against COVID or not. Okay, and the answer may have been unknown, but gathering the answers was not a matter of asking the public what they thought about it. It's a matter of having the data, which we didn't have at the time, and making the best medical judgments that could be made. It wasn't a matter of asking uninformed people what they thought.
Well,
hard problems are not solved by putting them to a vote. They're solved by gathering the technical information that's needed.
I do think you are an important voice to be heard and an important person, and I'm glad you were with us, and I'm anxious to post this on our global media accounts and let other people hear you and give them food for thought. But we're kind of stuck because, as you said, it's up to NASA to make to move us forward here, not up to Phil or AJ or Chaim or me.
Nor is it up to the public at large. The public at large hires the government to carry out public responsibilities, and they should do it well. It has not been done well recently.
Well, we don't hire well, but that's another story for another day. Mike, Merry Christmas and Happy New Year, and thank you very much for being with us tonight.
Merry Christmas and Happy New Year to all of you. I would apologize for being direct, but it's pointless because that's who I am.
No,
we like that.
And that's why you're here. And I hope to see you soon. Maybe if you're at AIAA in May in the Virginia, D.C. area, I'll be able to run into you again.
So,
thank
good night,
you.
folks.
Good night.
Merry Christmas.
Thanks very much.
Bye. So for those of you that are sticking around for a few minutes, I want to remind everybody that we're still doing our campaign. I'm sure many of you are sick of hearing that, and I'm sick of reminding you, but it requires action on your part. And I do depend on the public, unlike NASA. So if you like what we do and you like hearing programs such as the one you just heard and others, help us out and support us. If you're interested in the tax breaks, then your support should come to us at least postmarked if you're using the U.S. mail with a December 31st postmark. Otherwise, you get tax credit for 2026.
Yeah, but remember, if you don't itemize, then that's when you would want to be in 2026. But get it in early in the year.
Yeah, that's probably
don't hesitate beyond that.
Probably a little bit more advanced in what we do. But anyway, the website is the easiest way to support thespaceshow.com. Look for that PayPal button. It's large. It's on the right side. It tells you how to do PayPal. It goes directly to our PayPal account. If you want to use Zelle, again, I remind you, you have to have a United States bank. It's only a United States bank program. And every bank has it, including credit unions. Easy to set up. They don't take commissions, but we use a special email address to receive gifts through Zelle. David at giantleapfoundation.org. And then if you like mailing a check and being a little old school, our Las Vegas mailing address is on that PayPal button. If you're really glued into Substack and that's all you do, you can subscribe and join through Substack, and you probably know how to do that. We're Dr. Space, DoctorSpace.substack.com. And I don't really know about funding through YouTube, but I guess that's possible. But we're a little new to YouTube, and we are getting programs on YouTube, but I don't know how funding goes on YouTube. But it is important. I hope you will support us. We have a Friday new space show person testimonial commentary about supporting the space show. Tuesday's going to be an open lines program, and we've got other programs coming up between now and the end of the year. So, for example, Tom Olson does our end of the year program and has been doing it, I think, since the beginning of the space show. So he may have been doing it for 24 or 23 years. And he is going to do it again this year with us. He summarizes the space year. So that's this Sunday. And then Tuesday, the fundraising show, is the final space show program of the year. We do have a January 2nd program with our friend in India. Open lines will be a real open line show Sunday, January 4th. And we're starting to collect guests for 2026. Everybody, good night. And once again, Merry Christmas. And thank you for being here. And listeners, do support the space show. We look forward to your doing that. And hopefully we'll see you on another program and join us, and then you can be in these groups and join the party. And it is kind of a party. Right. Everybody be safe, and we'll talk to you Friday morning. Good night, everybody. Thank you.
Good night.
Good night.